Okay, YouTube, in this video we're going to look at another application of a linear system in which we have three unknowns. So let's go ahead and take a look at what we are working with here and talk about what it is that we're trying to determine. And so starting here, it says that at college play production, 350 tickets were sold. The ticket prices were $5, $8, and $12, and the total income from ticket sales was $2,700. Excuse me. So it asks how many of each ticket type were sold, okay? How many tickets of each type were sold if the combined number of $5 and $8 tickets was 6 times the number of 12 tickets? Excuse me. So answering this question, the question really is asking how many of each type of ticket were sold. And so it appears that there were 3 different types of tickets being sold. And so we'll go ahead and define 3 different variable types, but starting with the fact that we're going to say that this is the number of, and this would be tickets at, and I suppose our first ticket was at $5 per ticket. So this would be the number of tickets, okay, at, and our next price up was $8, and this will be the number of tickets at $12. And so now that we've defined these, our quest will be to set up our constraints for our system here. And so because we have 3, we'll want 3 equations. But going back to the problem, what we want to do is basically match up units. So I noticed that we had 350 tickets. It says that the ticket prices were $5, $8, and $12, and the total income was $2,700. And we were also told that the combined number of $5 and $8 tickets was 6 times the number of $12 tickets. So we'll start up here with this first number here. When you see this, 350 tickets, that really represents the sum of all of our tickets. And so if we knew how many X and Y and Z were sold, if we wanted the total number, then what we would really do is we would say, well, then the number of tickets sold at $5 plus the number of tickets sold at $8 plus the number of tickets sold at $12, this should come out to be 350 tickets. And so in terms of what this is, this would be like our tickets equation here. And we could say that we've accounted for this number. Now these next numbers, you notice these are all in dollars, and what that had to deal with was income. And so we could say, defining an income equation here, we would say, well, how would you figure out your income? I mean, think about this. If you knew how many of each type of ticket you sold and you knew how much you made off of each type of ticket, how could we find our total income? And so I suppose that if we knew that X was the number of tickets we sold at $5 and we made $5 for every one of those, then we could say the total number of money, the total amount of money we made off the $5 tickets is 5 times however many of those tickets we sell. Now likewise, we could say 8 times the number of tickets we sell at 8 plus 12 times the number of tickets that we sell at 12. This should come out to be a total income of $2,700. And so the neat thing is that now we've accounted for these numbers here and matched up our units. The last equation actually just comes from the comparison of these with one another. So what they read to us here is essentially that the combined number of $5 and $8 tickets, okay, that was or is 6 times the number of $12 tickets. So in terms of $5 tickets and $8 tickets, what numbers or what letters were we using to represent these? Well, we have X, okay, and Y. So when we say the combined number of X and Y, truly what we're saying is that X plus Y, their combined number, is or equals 6 times the number of tickets that we sold at $12, which we're using Z to represent. So for something like this here, I mean, I'm always going to recommend with your system like this, and this is just me, but kind of setting these back up in standard form so that we have our variables on the left and we have our constants on the right. I'm an addition method guy through and through. Now I will say that there are times where you certainly would just leave it the way it is because you've already got a variable solved for itself. But in this particular case, what we're going to do is we're going to bring this 6z back over to the left-hand side. And so what we get is stacking our variables as we would, x's underneath x's, y's underneath y's. We get x plus y minus 6z comes out to be 0. So I'm going to put a box around this. We're going to say, okay, well then this is our system. And so if this is what we're going to work with, then I think that the first thing we want to do is assess the situation, find out which variable it is that we want to cancel out. So our goal, remember our goal with a 3 by 3 system like this, is to, using 2 different pairs of equations, cancel out one of the variables. And so my choice, and this is just me, I notice just because 8 is pretty big and 12 is pretty big, and I don't want to deal with those, I'm going to cancel out x's in 2 sets of equations or 2 pairs of equations. So the first one I'm going to deal with is this. If I were to take this entire first equation times a -5 and add that to my second equation. So if we were to do this, I would get negative 5x minus 5y minus 5z, and that would equal negative 5 times 350. So looking at this on a calculator here, I'll go ahead and turn this back on. We would say that we get negative 5 times 350. We would get negative 1750 on the right side. So now, adding this to the second equation, which is 5x plus 8y, okay, plus 12z's equals 2700, what we're going to get is that our x's cancel out here. And so we're left with 3y's, okay, we're left with 7z's. And if we were to take this away, we could say that, let's see, plus 2700 is 950. So 950, and we'll put a box around this. This is well, one of our equations that has just two variables in it. So now, because I used equations 1 and 2 last time, I'm either going to use 1 and 3 or 2 and 3, and I noticed that if I were to just use 1 and 3, this would be pretty neat, because all I'd have to do is just take one of these times a negative 1. And so I'm going to choose to take my entire first equation times a negative 1 here and rewrite my system. And so what we end up with is just negative x minus y minus z equals a negative 350. And our third equation here, our third equation was x plus y plus, minus 6z is equal to 0. So summing these up, what we end up with here is this. We actually get our y's to cancel out along with our x's, and we end up with negative 7z is equal to negative 350. So something really cool happens here. We're actually able, from this single expression right here, able to solve for z here by taking our negative 350, okay, and dividing by a negative 7, we get 50. So we've discovered now that z is 50. I'm already going to write then our solution. We say our solution, okay, has a z value of 50. So that being said, we say, well, what do we want to find now? Well, we want to find x and y. So we've got all of these different equations we can choose from. But I'll tell you what, when we plug this back in here, I suppose that because if we're looking for y, we could plug it back into, this equation here and solve for y. So we have 3y plus 7 times z is equal to 950. Plugging this 50 back in, we know that 7 times 50 here, that would be 350. So 350 is 950. And as we subtract 350 from both sides of this equation, what we determine is that 3y must be equal to 600, and it follows that y therefore is equal to 200. So now we have z. Now we also have y is 200. Let's go back and solve for x. And looking at this, our very first equation, x plus y plus z, is 350. That would be a very, very easy equation to deal with. So we'd say x, okay, we know not x, but we know y, and we know z. We know that all of these add up to 350. So if z is 50 and our y value is 200, then combining these here, I suppose we get x plus 250 is equal to 350, and subtracting 250 from both sides here, what we end up with is that x is equal to 100. And so we're going to fill this in here. So now, when all is said and done, essentially what we want to do is, you could plug this back into all of your equations to check to see that it works, but we want to interpret this. And so because my handwriting is just so poor, I'm very sorry, what I'm going to do is I'm going to type this here. But we must have sold, basically, when we look at X, Y, and Z, this is a number of tickets. We sold 100 at $5, 200 at $8, and 50 at $12. We would say 100 tickets sold at $5. We had 200 tickets sold at $8, and 50 tickets sold at $12. Cheers.